Hello guys and dolls, welcome back to Honey Badger 3D Print and Paint. Today we are at Formnext 2024. We have got loads coming for you. We are sponsored this year by Sunlu. Take a look in the video description for a link and a discount code. Just to be clear, it's an affiliate link, helps the channel out. Let's take a look at some of the amazing tech that is on display at the show. Hello guys and dolls, welcome back. We are at the Mosaic booth. I'm here with Robert. Talk to us a little bit about Mosaic and Elements.
Absolutely. So I'm Robert. I've been working at Mosaic for about 3.5 years now. I'm on the sales engineering team. And in front of me here is our Element. So Element is our industrial high temperature 3D printer that is also multi-material, multicolor capable. So right now we're actually printing with a heated chamber, 80 Celsius, 120 Celsius bed, and we're actually printing PEEK. So this is a material that usually reserved for sort of really high-end applications and usually found in printers that are $50,000 plus. We've now done all of this, packaged it down into a printer, made in Canada for $10,000. You can go out of the box, print PEEK.
Okay, great. So let's just be clear about how much of an actual achievement that is, because PEEK is normally, it's basically an oven that someone's tried to put a 3D printer inside. It's incredibly complicated to do because you can't really cool the thing outside of liquid. Yeah. And it's not just we made a hot end that went hotter than the previous hot ends. Well, this is end to end built to do high temperature, right?
Yeah, exactly. So like you said, sure, you could build a printer with a hot end that goes that hot, but if everything else isn't designed around printing these high temp materials, so for example, our entire build chassis is all steel. So that way your thermal expansion is going to be the same across all of it. So when you have that heated chamber, you're not going to get weird print artifacts or bad precision in your prints. Everything's going to expand the same. So you're going to get those great quality prints with PEEK. But again, at that price performance of $10,000 a unit, not $50,000 plus that we sort of traditionally see machines sort of this caliber.
It makes it a really compelling business case when we start to talk at scale, right? Because when we're talking £10,000 a unit, we're not talking about the prosumer market or the consumer market. We're very much talking about people who are doing manufacturing. But when you start to think about the individual machines at this price point, then all of a sudden Array, which we'll move on to at a moment, becomes a really compelling business case, because you get a fully mapped workflow with multiple machines that basically drops into your workspace without you having to create a whole farm environment to be able to support it. So talk to me about the material cartridges as well, because obviously you've got Element as a unit, but then you've got multi-material cartridges that fit on the side. So How does that all work together?
Exactly. So every element, whether it's high temperature or low temperature elements, they have the ability to hold up to 8 different materials. So with these carts on the side, you can actually just click it in, unplugs just like this, and then we can open it up. You put your material spool in here. We have desiccant inside. It's magnetically sealed with a gasket. So
these are active. These are active extruders, though, right?
Yeah,
this isn't right. Okay, cool.
Exactly. So there's actually 2 motors in here. One motor has will spin this turntable, retract the filament, keep it tight on the spool. We also have one that will push filament forward to your print head.
Right.
We also have a cutter inside of the system. So when I want to say change my print from, if I did ABS and then I want to go print carbon fiber nylon, I don't have to go and manually pull the filament out, feed my new filament in. This system will do all of that automatically for me. So when I plug my material into this system, it knows what material it is, what color it is, how much is left on the spool, and it just knows when I want to go print, it will pick the right one out of the 8 that are connected.
Right. So your multi-material stuff that started, you started with pallet, right?
Exactly.
So this is your sort of your pedigree stuff. This is the multi-material side, initially trying that with pallet, and this is the sort of the next stage of that.
Yeah,
right?
So this is basically the evolution of pallet. So we had a lot of customers, a lot of sort of consumers were buying pallet, but we noticed there's a lot of industrial users were buying pallet and they're looking to get more out of it. They're saying, hey, we're using this for filament run out, but we want more automation. We want more automation. And eventually we built that into our printers. And that's also just what led to the whole concept of the array system behind us, was just kind of that ask for more automation.
So, I mean, what kind of speeds are we talking about with these? Because high temperature comes with it a lot of engineering complications, and it means that speed isn't always what you can achieve.
Yeah, so speed is generally not paramount for people that are printing things like Peak. What they care about is performance, quality, reliability, repeatability. So when we're printing high temp materials, we're going to be between 40 and 60 millimeters a second, just to make sure that we are sort of, again, maintaining that repeatability, quality, and just sort of precision that you want in a part like this.
Okay. So when it comes to scalability, let's have a chat about array.
Yes.
Because it's so cool. And I can't have one for very obvious financial reasons. But, but I still think it's really cool. So let's go check that out.
All right, let's go over.
Cool. So here we are at array. Array, this particular array is set up as 4 machines, plates that it then loads into the bed, and then empty plates that are filled with print. But talk to me about array, because this is one configuration of it.
Yeah.
But how big does array go? Is this like the standard size and you just buy more of them? Or
Yeah,
is it,
exactly.
Right?
So this is a standard size of array. So we're actually looking at 4 of these same printers we saw before. So we have 1 element here, 3 there. So the same specs we saw in there, high temp capable, 355 millimeter cube build volume, and same great features of multi-material, multicolor, all work in the system. But now you just get lights out production.
I mean, this is a huge, just to be clear, this is a huge print volume. So what's the bed size on this?
355 by 355.
I mean, so it's a huge print volume in just one machine anyway. And you've got 4 of them, ready to go, basically a drop-in farm.
Yeah, it's basically almost think of like it's a part vending machine.
Yeah.
Right? So you can just come up, when your print's done, it's going to take it out, store it in there. So you can come into Friday morning, send 100 prints to the system.
Yeah.
It will figure out where each print's supposed to go based on what materials connected to each printer, stores it all away. You come back Monday morning.
Yeah.
Your job's done for you. You can go do other things.
There's a lot of imperfect solutions to trying to get machines running 24/7, right? The most imperfect solution is just employ a person to come and take all the beds off, and it's super expensive, and then those people steal or whatever. There is an imperfect way of dealing with a 24/7 operation. With this, you're not even really worried about. So again, a lot of them try to sweep the parts off, and you'll get material damages as well as potentially damaging the build surfaces, and then as well the fact that it just might fail the next print because that bed doesn't work properly. So you're taking the whole print bed out, storing it. Someone's coming along, taking all those parts out in the morning, and unless it runs out of rack space here, then ultimately, and these go back double width?
So
right?
it's double width. So this whole thing has been designed for 72 hours of lights out operation.
Right.
So that means, again, Friday morning, send in your queue of prints, do other stuff, come back Monday morning, your part's now full, take it out, get all your parts ready to go, and don't have to worry about swapping build plates out.
So talk to me about the software behind this, because this is a very complicated set of things to control. It's farm management, queue management, machine availability, and everything else.
Yeah. So
talk to me about the software side.
So definitely very complicated system, but with our software, it becomes very simple for anyone to use it, even if you're not a 3D printing professional, expert, really unskilled labor. You can come in and you can get trained up on this in a day and you'll be ready to go. So for the software, for the array here, we have 2 versions. We have Canvas Cloud. So this is where it is a cloud-based slicing software as well as project management. You can think of it almost like a Google Drive, but for all of your sliced projects, material management, printer management. So you can have an organization of people. They can all have their own log on, and you have a sort of home directory where everyone can share files, see what other people are doing. You also have your own private area. You're the only one making these prints, so no one else can see them. And then we actually just announced at the start of Formnext this year is Canvas Desktop. So for clients where security is paramount, they can't touch the cloud, we keep everything localized on a desktop version that will interface with this system.
So that's really important. There's a lot of different industries that do rapid prototyping at scale, and a lot of those would be companies that have very stringent NDA and security criteria.
Exactly.
The cloud is a computer in somebody else's house. Let's just be really clear about that. We can pretend that the cloud is an ethereal thing. It's just that the PC used to be at your house and now it has gone and this is somebody else's. there's a lot of security concerns when it comes to cloud computing, especially when you're dealing with aerospace engineering and you're trying to do rapid stuff. It can be a lot of IP concerns and all of that. But by bringing that to desktop, you're effectively eliminating the
So
security
there's
concern.
zero cloud connection. There is no one's phoning home through this system. It lives on your PC with all of your files, so you don't have to worry about that. And it will work on both Mac, Linux, and Windows.
So how does this link with front end? Are there API callouts that you can do that automatically take a store sale directly through to a print queue? Or is there still somebody still needs to initiate something for a queue to exist?
Yeah, so right now there's still someone who's going to initiate the queue. So they'll go into the software, they'll slice the file, and then you can click send to array, and it'll give you the quantity. So if you want to send 100 parts, you type in 100, boom, you have 100 prints being done.
Right.
So all of that.
So it's still targeted really at mass manufacturing, not necessarily storefront.
Yeah, not a storefront yet, but we'll get there. You know, there's been work being done on the back end on that side of things. So
Cool.
we'll never say no there.
It's obvious. I mean, the thing that difficulty with when you're trying to do mass manufacturing at this scale is that generally speaking, you have to build something completely bespoke. You have to have really specific requirements that you have to articulate to be able to build a business case. This is just a ready dropped in device that rolls into your, I say roll, it's craned in more than likely. But
it can roll. There is actually wheels on the bottom.
Oh, I'm glad I'm not moving it around the show. So this just comes in and you have a ready built workflow with large build volumes, capable machines, automated print flow, automated software. It's a ready-made factory that you can just roll into a space and off you go.
Exactly. And what makes it so great and so easy and sort of ready to go is the fact that it's not just a materials ecosystem. We have a materials ecosystem, hardware, and software. So we've combined all three of those things. So you have the most reliable, easy-to-use experience. So day one, once this has been built up in your shop, within an hour of being trained on it, you are ready to go and start a huge queue of prints, regardless of what materials, anything, all that's sort of pre-prep for you. We have a materials team.
How's it dealing with fault detection? So, I mean, faults happen, right? There's no machine is impervious to them. So how's it dealing with failed prints? Or how's it detected? Can it detect?
Yeah, so we actually have cameras inside each of the printers. So there's the old manual method of you can look through the camera and you just see if something's going on, like pause or cancel. That's a lot of labor. That's kind of annoying. So we built a AI solution that essentially can look at the print, say, oh, I'm seeing spaghetti. Okay, we'll cancel that print. It'll store it, restart that print for you automatically.
So it will clear the error. There's still no manual intervention with that.
Yeah, so it'll say there's an error.
It just takes the
You'll get a
out.
notification. Hey, printer 2, we're seeing error printing. We're seeing spaghetti. If we essentially cancel that for you, and then it'll can either say like redo the print or just deactivate that printer. Wait till someone has to go there if there is, say, a larger issue. And we also have a bunch of sensors built into the print head, so we have an encoder. So we actually can not only see if filament is there, we can see if it's moving. Right. So if you had a print head jam, it's not just going to air print nowhere. It'll say, okay, there's an encoder here, so we know filament's not moving.
That would
now require some sort of maintenance, but it'll know, and essentially, so now it'll disable that printer. Then let's say you still have a big queue of prints. It will now just put those prints to the other 3 printers.
Right. Okay. Fair enough.
Yeah.
I feel like that's just finished. Am I about to see this going?
Yes, I had it disabled just so it was sitting down there, so it wasn't kind of distracting the viewers. But we can activate the gantry here. So once that's done, we'll see the printer here. This one's done. So now it's lowering its bed. So it'll come down to the bottom of the printer.
Yeah.
And then once it's there, the gantry will actually come up, scoop that up, and then throw it into the cart here.
So how are you dealing with? So is everything in here a high temp, and do you separate out high temp and low temp machines? Because you must get temp in this sort of enclosed space. You must get some sort of temperature bleeds, right?
Yeah. So we actually have HEPA fans at every printer that works as a filtration system, but also if I'm printing PEEP here, I can print PLA here, no problem. These printers are all metal. They're very well enclosed and insulated, so you're not going to have
thermally isolated from each other.
Exactly. And the gantry will actually close the door. So if I'm printing something, let's say like PEEP, it will physically close that door. Again, separate that from the other systems and heat up. But like you were mentioning earlier about, can you have different configurations? You can. So elements, they can all be low temperature elements that don't have chamber heaters. So you could buy your array with 4 low temperature elements, and then maybe down the line, you have a client who really wants PEEP prints. You can buy an upgrade kit for just that one printer, and you can Within 20 minutes, you click into chamber heaters in the back of it.
Augment your workflow.
Augment
it when you need to.
Exactly. So it's fully modular, which is a really nice feature of the system. And again, almost back to that error detection. If you do have an error with the printer, these are actually just slotted in here. You could take the entire printer out and just have 3 printers in here. Fix them on the outside.
I mean, so obviously there's big plates and everything in here, but are these functionally they're just those, right?
They are literally just those packaged different.
Right,
a little
because
bit
I'm
tighter
assuming
to
their
fit in.
material units are on the back,
Yeah,
right?
exactly.
Right, okay, it makes sense. So just going to watch this because I've seen different solutions where companies have like a full robotic arm that looks like it's about to rip someone in half.
Yeah.
So I just want to see how it actually gets. Oh, so it's literally this.
Yeah, so the way this works, what it's going to do right now, it's actually going to scan to figure out where the bed is. So it's not just going to a dumb position or a set fixed point, because maybe things change or the bed could be a little bit shifted in the way it's installed. So we actually go in and we'll do a closed loop scan. So we know exactly where the bed is, and then it can move relative to that. So actually we'll scan for those cutouts inside of that bed, know exactly where the hole is, and then I can go and pick it up. So we'll start from above, scan, figure out where those holes are, and then it will come from under it and just goes through that hole punch and then pulls it out. So maybe wondering, why is this going so slow? At the end of the day, this is maybe a 5-minute workflow to remove a print, put it away. If your print's 10 hours, that extra 5 minutes doesn't really matter.
Yeah.
And when you're doing large-scale automation, reliability is paramount, because if you have failures in workflows like this, you're now automating failures, you're not automating production.
Yeah. What? Oh, it's dead in the center as well.
Yeah, it doesn't miss.
So there's sort of like this. I don't think you can see it on the camera, but there's a pin right here, and the pin, and again there's a pin that goes into like a hole that pulls the actual bed off, and it's a magnetic spring steel bed, but then you've also got sensors in here so that it can detect when the bed has been successfully pulled all the way out before it goes off to do something else. And again, you have to bear in mind here, this is about unattended continuous workflow. So yes, this is not a specifically quick process, but generally speaking, you wouldn't be printing hexagons. They're sort of polyhedral, whatever they are. You wouldn't be printing things like that. You would be printing full build sheets that would then be coming off and then moving across. And
so it's a 15-minute print. It doesn't make a lot of sense.
It's not like the other machines would normally be waiting and finish at exactly the same time. So the fact that it's doing this and it takes sort of 5 minutes to do, it's better that it does it slowly and 100% accurately than it is that it does it very quickly, but for no real benefit by the end of it. Because the whole point of this is volume and workflow and everything else.
Exactly, yeah. And it's repeatability and just industrial reliability is, at the end of the day, all that matters to the customers of a system like this.
Yeah. Well, look, I mean, it does it. It's cool. It's really big. Do I want another price? I feel like I do. It'll upset me.
Yeah.
Is the price for a unit this size?
Well, for you or just in general?
I probably in general. I think if we're targeting at me, it's probably a touch ambitious and would upset me more.
So Array starts at $80,000 USD, and that would be low temperature configuration on all 4 printers.
Right.
And if you want high temp configuration for all 4 printers, you're now looking at about $100,000.
But that's still 4 machines. That's still a relatively simplistic return on investment business case.
And the big thing you're thinking about, you're spending $80,000 on 4 printers and no human.
Yeah.
If I have a print farm of 10 printers and I'm paying someone $60,000 a year to manage it, it doesn't take that long for this to win out. And they're not
a skilled engineer who's going to be able to do some level of maintenance on them. But what you don't need is a skilled person monitoring 10 individual machines all the time, because you're just doubling this up until you've basically got someone who's just coming and taking things off of build plates.
Exactly. And
it changes your labor dynamic completely. Well, I mean, very cool. Obviously, I want one. I don't think Mosaic are going to send me one, but hey, maybe if this video got like 10 million views, then
10 million?
I think even then they'd say, no, you can't have it. But it would be nice to be able to say it. So that's cool. Thanks very much for the time.
Yes.
Catch you on the next video.
Thank you.
See you later.